And force analysis. Our main aim is this one. What is that of the force analysis? Here we need to find out the forces that are produced in the different members of the truss here. So how will you find out? What is the technique that we use here? Okay, by assuming the stress is in the equilibrium. Okay, that stress is in the equilibrium. Okay, so whenever the stress is in the equilibrium, actually this is a plane stress. Whenever the planar problem, then when you apply the equilibrium, what are the equilibrium conditions? The equilibrium conditions are sigma fx equal to 0 and then sigma fy equal to 0. Okay, and then see, generally these two are enough when the forces are concurrent. Okay, plane, okay, coplanar and concurrent. Coplanar and concurrent, then by applying these two equations we can solve that. Already we have seen in the previous cases. Okay, but what happens if these are non-concurrent? That means all the forces are not intersecting at one point. In that case we need to use the moment equation also. Sigma m equal to 0, and how is the moment here in this case? The moment here in this case is perpendicular to the plane. Okay, the moment is perpendicular to the plane whichever you have the stress. Stress means stress, S-T-R-U-S-S, not S-T-R-E-S-S, stress. Okay, so we need to apply these formulas, and then here most of the time we apply all these three together. Why? Because here in this case the forces are non-concurrent, and here these members are simply the cylinder or the rod subjected to either tension or the compression. Okay, it is subjected to the either tension or compression. Okay, so the one which is subjected to the tension is called as the tie member, and the one which is subjected to the compression is a strut member. For example, here whenever I say that some rod is subjected to the tension, let's assume this is the rod, okay, weightless rod, and it is subjected to the tension. Tension means the forces are like this. Okay, so the forces are like this on this rod. Okay, that means they are trying to stretch the rod like this. Okay, and whenever I say that the compression on the rod, then the forces are like this. They are trying to compress the rod like this. They are trying to compress here. Okay, and how these forces are represented in case of a stress at in the rod and as well as at the junctions. For example, I will take a simple example. What is that? I will take a simple triangular stress like this. Okay, this is a simple triangular stress, and these are the joints. So, and these joints are named as A, B, and then C here. And here, if I apply some vertical force F at the joint C like this, then how the force is how is the force in the AC and as well as in the BC? By the observation I can assume that this is the compressive force. Okay, so in case if you are unable to observe whether it is a compressive or a tensile, then in that case always we will take the tensile. We will see that how to take that. So here let's assume that BC is subjected to the compressive here. So if I cut this BC here and then take the rod like this here for the BC, then the compressive force is like this. Okay, so what is the meaning of this? The rod BC is being compressed between these two joints B and C. So the joints are pressing the rod like this, and whenever the joints are pressing the rod, then the rod also will exert the same amount of force in the opposite direction. Okay, So that is the Newton third law. So this is the CB, and then if I take the joint C here, if I take the joint C, so at the joint C, how is the force FCB? FCB means in this direction CB. Okay, how is the force in which direction? Arrow mark downward or upward? Whenever you, what is the free body diagram? Whatever you are taking the the body in the sense here, I want to draw the free body diagram for this rod, but whereas here the free body diagram for the joint, so that the force is acting on the joint. So here the rod is trying to push back the joint, so that the forces are in this direction. Understood? So this is the joint C. This is the FC is acting on this joint C like this, and whereas the FCB here in this case rod is acting like this. And if I want to represent the same line, then how will I represent this? This is the rod. Okay, the forces on this rod is like this. What is that? FCB, and here also FCB, and here if I cut at the junction, the force on the junction is in the opposite direction of wherever we cut that. Understood? In the same way, for example, there is a rod like this, and this rod is subjected to the tension like this. Okay, and here the corresponding junction for this rod, and how is the force direction at this junction? The force direction is like this. Okay, always opposite arrow of this. Okay, so the force at this junction is like this. Understood? This is the junction and this is the rod. Okay, that is where we need to represent the forces. Okay, at in the rod and as well as at this junction because of that rod. And here always there is a confusion, like sometimes by observation you can easily say that whether the tension or the compression produced in the rod, but most of the time even I myself I'm not that much great, but I'm saying with practice also I myself confuses. Even anyone can confuse us. In that case, what we need to assume. Okay, so how will you take the sense? Otherwise, nature of force in rod. What is the meaning of the nature of force in the rod? That means whether it is a tension or the compression. Okay, so here by observation we will first mark whether it is a tension or a compression. If you fail to identify that by observation, then now you always assume it is a tension. It is a tension. So what is the meaning of that? When you assume it as a tension, then whatever value you will get finally, if it is a positive, okay, whatever value you will get finally, final value is positive, okay, then whatever you assume, this is the correct. And if the final value whatever you obtained is a negative, then whatever value or whatever nature that you consider is not correct. That means here it is a compressive. Understood? So you need to reverse the direction of the forces there. Okay, that is one thing you need to remember here. And how will we find out forces different members here? Okay, once if you know the forces, then you can find out the stresses if the dimensions are given. For first thing is first focus is we need to find out the forces. How will you find out? Of course we will use the equilibrium condition, and apart from that we will use different methods so that it will be simplified. What are those methods? The first method here is called as the method of joints. So here, so this is a method of joints, and the second method is called as the method of sections. What is, and the third one is called as the graphical method. Okay, third one is a graphical method, and here the name itself is indicating what is that. The method of joints means here the main focus is by considering the forces at the joint, okay, at different joints, and we will apply the equilibrium conditions, okay. And the next method is by taking the sections. Sections means, we will take the rod, we will cut the rod and then take the cross section of the rod, or the forces that are acting on the cross section of the rods, okay. That is the meaning of the sections here, okay. And then graphical method, we are not going to deal the graphical method, but we will concentrate mostly on the method of joints and the method of section. And out of this method of section is very much important. Why? Because it will easily simplify the problem, okay. So for the GATE examination point of view, or even for the IES prelims, we will adopt this method of sections here, okay. And further we move, before we move further, I would like to mention one more important concept, that is the zero force members.